Okay, so you've probably been looking for a video editing system and want to know what the actual lowdown is. Now, there's a lot of people doing a lot of videos online, and most of them miss out critical factors. Now, for those who are video editors, you'll know that you have a 63,600 megabyte a second raw data rate, and 4K video output rendered is 17 megabits or megabytes a second. A system that actually works, you need to meet the data rate of the system to be able for it to perform as it should. Go out and buy the right hardware to do the right job. Now, a lot of people who edit video will more likely be concerned with render times and raw video times, and how you cut down on your time having to render and edit videos. Now, video editing and video rendering are two different things, but you still have quite a lot of raw data to actually put through. So I've looked at a lot of information and what is available, and technology is just about there. So I'm looking over at my screens here, and I'll show you shortly that what we're looking at is where the problems are with computer systems and the bottlenecks which slow things down. Now, the hard drives have always been a problem. When I was developing the Ultima computer systems, we always had problems with your hard drive or solid drives being relatively slow to everything else. So with the advent of SATA 3 and M.2 drives, the data rates are obviously a lot higher, and therefore you're not slowed so much. So what we're looking at is M.2 G, or Genie, which brings up your data rates to 2,806 megabytes per second read, and a write of 1146 megabytes. So those are an hour long 4K video is going to be about 764 gigabytes. So near enough a terabyte of data, which obviously most of the drives speed does drop off and you don't get those speeds. So we're looking at something which will, on here, shows 28,000 megabits, which is quite good for doing raw data frames. But the problem is that that's obviously the top speed, and it will drop down to theoretically the data rate and max capacity. But what you also need to do is, depending on what software you're using, it will depend on the PQI rating, or how many gigs a second the processors can actually handle, and that includes the motherboard, the RAM and the processor, and for some software users your graphics card. Now, I'm just going to flip over so I'm actually using real world references. The NVIDIA RTX card, Titan RTX, it's a £2,000 card. It's got 24 gigs of GDR6 on it, and it has a total memory bandwidth of 672 gigs per second. But it also says the memory data rate is 14 gigs per second. So you have a 4K just, but the total memory bandwidth is 672 gigabytes, bytes a second. And so that would theoretically offer you the speeds that you need to be able to do it. So the problem is how do you mix the two together? Now, a processor will do about 7.6 gigs a second. So basically you can do the maths down on a piece of paper, and you can say, well, if I'm video editing an hour of 4K video, I need 764 gigs. So we can do that in an array. Let me put up the calculator. And we can do 764 divided by 2 is 382. So you're looking at around about probably a 500 gig M.2 drive, which are incredibly expensive. Your alternatives are 8 SATA 3 drives and 2 or 4 SAS drives. That's 12 gigs a second, and SATA is obviously, the SATA 3 is 6 gigs a second. So you need to work out where your cost point is, because we're not talking about money, we're talking about which way to do it for the best price. So your best prices are your SATA 3 drives. They're obviously going to be the cheaper ones, but by the time you get up to a certain amount, the overheads for controlling them slow the system down. So that's probably not the best way to go. But what you could do is you could go along SAS drives, which are network enterprise drives, which are expensive as much as they are, but you need less of them. And you may have to buy a controller card because your motherboard won't have one unless you're using a server board. So you've got to take up the pros and cons, and they will come at various price points all the way through. Although if you're going to run near on 8 SATA drives, then that will push your overhead way over, and you would probably be better off getting a dedicated PCI Express 16 to deal with that. So looking at M.2, it's supposed to run at about 2,500 megabits a second, and your Evo 860 Pro will run at about 550 per second write and 520 read. So that's about half the speed of an M.2 drive. So what we need to do is to find something that will best match our raw data rate. Now that depends on how you render, whether you're interleaving or progressive, IMP, for the data rates, because you won't get a full 8.85 megapixel frame, and therefore you have to work out what that's going to be. So it's going to be like 1060 megabits a second, which for the Evo is twice the drive speed, sorry. And for M.2 running at full speed, then you should have no problems with it, although the theoretical write is slightly slower. So technically, do you use SAS drives, which will hold the speed, and they're 15K drives, or do you go for the M.2, which has 2,500 read, write, and 1,000 read, write. Yeah, so I didn't put the read and write on it, so it just makes it a bit difficult. So what you need to do then is, if you had it in RAID 0, that would be 5,000 and 2,000, which puts you up in the right speed for raw data processing. So that's not going to be a big issue. But if you want to go M.2, you're going to need 382 minimum gigabytes of space. You're going to need 2 of them, and you'll have to run them in RAID 0, and then you need to be able to do over 63,600 megabits a second in RAW format rendering. So your 63 would put you up with your NVIDIA Titanium RTX card, and that should bring you all the way across. So the motherboards you'll need are the newest generations, which will be the X750 with M.2 in RAID array 0, and then you'll need a processor. Now most of the processors do about 7 gigs a second, so you're not going to be you're going to be up at the upper end. I've got a system here with a 2500K, and that's running at around about either 4.6 or 5 gigs a second, so that doesn't really bottleneck the system. It will run at top speed because of the data rates that are going through it, because when you're rendering, you're sending the information up to the system and then it's coming back down, so theoretically you have to have twice the bandwidth to be able to cope with the data flow, and that's basically how how video editing works is data in, data out. System bus has to have twice the amount of data. Exactly the same happens with your hard drive systems if you're reading and writing to them. So when you have your M.2 RAID array, that would be perfectly fine for rendering the system, but you need to be able to shove that over to the RAM rather than running off the main system. And so it would be 65 gigs of RAM you would technically need. If you have that size RAM, then you should know you won't get a bottleneck on your RAM at all, and you should be perfectly fine in all types of formats and all types of rendering. So that's basically the summary of how a video system should be set up, and what a lot of the videos on YouTube are missing out on is a theoretical saying, oh, you need this solid state drive, but it doesn't actually say, well, actually it's pretty crap, because the data rate is half that of your actual data that you're trying to work with. So that isn't really going to work for you, and that will slow you down. The only way you can actually do it is by probably using a JBOB, which is essentially, or RAID, where you're pulling data from 3 disks as one, so you're technically or theoretically tripling the speed, because that will give you your better speed for dealing with the data that you need to deal with at the time of what the system will request. So anything over, if you look at the PQIs of the process, it should give you a rough idea, but don't forget it's probably going to be 20% lower than what it says. And you're going to get system overheads on top of that as well. So if you've got a heavy operating system like Windows, you're always going to get a heavier overhead. So you're looking at 30% to 35% overheads. So whatever the data rate is, or data throughput, you need to take off 30% of that, but also be fixed to what your data rate is when doing 4K video, that you are going to be using quite a huge amount of data, because you're looking at your frame size, your megapixel size, not your bit rates, because they're different. Each individual frame is a set size. Your rendering is a completely different size, and that's why you end up with 17 megs a second rather than over a gig a second. So it's worth thinking about, and it's just down to playing off which is going to give you the best situation for your money, how long you want to spend on it, time, and how much money you're willing to spend on a video editing system. Now, when I used to build video editing and graphic design systems, they would cost around about £5,000 to £7,000, and that is because they were specifically designed with all the correct hardware to make the job easier. And I remember we sent one out, and another technician had gone out and said, and then we contacted the guy who contacted us again. He said that his other guy had turned around and said to him it was the fastest computer systems he'd ever seen. But we make the ultimate computer, so we have the ultimate speed. So that was what it was like back then. But now you've got so many different competing technologies, and some of them are limiting and some of them are not limiting. You don't have so much limits and so many holdbacks, but then you're not processing the data at the same rates. We would be doing 720 in HD video, which on most modern systems they can breeze through it no problem at all. Just whack a solid state drive in and you can be editing in relatively real time. But that's the way it is. So if you have any questions, just shove them below. I'll be making loads of rubbish videos about loads of different subjects, and you'll quite, if you want to subscribe, but you know, I do lots of different things. So the next videos are going to be on about server arrays, because I've been doing quite a few server arrays, and you can't see around you at the mess. So we're waiting for some parts to come in so that we can rebuild servers. But we have been looking at a lot of different things, and it's a matter of whether the technology works with the hardware. So we've got tons of stuff anyway. So we'll be looking at, can you buy an old system, shove it in a corner and use it for video editing, and will it be better than having to fork out for a complete new system? The answer technically is actually yes. You can buy a video editing system for around about £80, so that's British pounds, and so that would be quite an interesting video to watch, I'm sure, for some people, of how to do it. But you can't use certain software programs for doing your video editing because of the way the systems are set up, but you can buy specific ones and buy extra bits, so you can pay less than £700, say, for a competent video editing system. So I'll be dealing with that on another video. We're just waiting for some hardware to arrive and some parts to repair and recap servers, and well, if you want to subscribe.